proofs of complement laws. So here we are going to prove the complement laws of equivalent fundamentals statements. So here we are going to prove the complements, or in other words the complement laws of equivalent fundamental statements under the advanced level. So in order to prove the complements or the complement laws of the equivalent fundamental operations, so we have to suppose a statement. Let the statement be P. So here it has the truth values as one as true, the other as false, but not the both. Then the complement laws states that one as P or negation P is identically equals to T is the first one, and P and negation P is identically equals to false as the second one, and the negation of negation P is identically equals to P, and the negation of T is identically equals to F, and the negation of F is identically equals to T. These are the 5 complements or the complement laws of equivalent fundamental statements. Then now the complement laws of equivalent fundamental statements are of, then under the case number 1 we are going to prove the first two, that as P or negation P is identically equals to T, and the second one as P and negation P is identically equals to F. And whereas under the case number 2 we are going to prove the complement laws as negation of negation P is identically equals to P, and negation of T is identically equals to F, and the third one as negation of F is identically equals to T. Then now the proof starts for all the cases. Then now we are going to prove as per the conditions which are given to us, or the statements which are given to us are of. So here case number 1 is of P or negation P is identically equals to T, then the second one is P and negation P is identically equals to F in the case number 1, whereas in the case number 2 we have to prove that negation of negation P is identically equals to P, and negation of T is equals to false, and the negation of false is the true statement. These are the 5 cases which we are going to prove under the complement laws or the complements. Then now the next logical step, so the conditions which are going to prove under the complement laws are of. So this is of case number 1. Under the case number 1 we are going to suppose a statement. So here let P be a statement, then it has 2 truth values, one as T and other as false. The condition which we are going to prove under the case number 1 are of P or negation P is identically equals to T, and the second one as P and negation P is identically equals to f. Then now the truth values, based upon the truth values, whereas in these truth tables, so we can prove P or negation P is identical equals to 2 in the first case. So this is the truth table of the first one, and this has the truth table of the second case, that is P and negation P is identical equals to f. So here, as per the condition, so we have to suppose one statement, that is P. So here this is our, under the column number 1, I suppose the statement as P. Then now I have to find out negation P in order to prove this statement, that is P or negation P is identical equals to P. Then now second column is of negation P. Then overall on the left hand side, so it is of P or negation P. Then as the fourth column, so I have to take T. Then whereas in the second case, so we have to suppose in the similar manner one statement as P, and whereas in the second column we need negation P, and in the third case the left hand side statement, simple statement, is of P and negation P, whereas the fourth column consists of the false statement, that is F. So here these are the four columns of the first statement, and these are the next four columns of the next statement, that is P and negation P is identically equals to F. Then now here we know that if a statement is supposed, then it has two truth values, it may be either true or false. Therefore we are assuming the truth values of the first statement P as one as true and another as false. Negation of P, so here in order to find out the negation of P, so it can also be read as the not P. So here the truth value of the first statement P is of true, then in order to find out the negation P, that is not P, so here it is of not true, so then automatically it must be of false statement. Then if P is of false, then the negation of that P statement will be of true. Then now here in the third column we have to find out P or negation P. So here or indicates the disjunction of the two sets, that is two statements, that is P and as well as negation P. So in case of the condition of the disjunction is off, if first statement is of false and the second statement negation P is also of false, then the disjunction also will be of false. Then now, so we have to search for F and F. The first statement P must be of false and the second statement also must be of false, then only we will be getting the disjunction as false. Whereas here F and F, so here there is no case which consists of what I say, a first statement as false and the second statement as false. One is of T and F, the other is of F and T. There is no F and F, therefore we won't get the disjunction as false, so we will be getting the statements as disjunctions as true. But here T indicates the truth values of as true, so here both the truth values will be of true in the first case. Then now in the second case, so in order to prove P and negation P is identically equals to F, so here we have supposed one statement as P, therefore the truth values may be either true or false. In order to find out the negation of P, so here the statement P is of true, therefore its negation will be of false. Similarly, the truth value of the negation of the statement P is of false, therefore its negation will be of true. In order to find out P and negation P under the third column, so here since it is P and, so it will come under the conjunction. In case of a conjunction of a two statements, that is P and as well as negation P, so here the condition is of the first statement is of true and the second statement is also of true, then the conjunction also will be of true. So here P must be of true and the negation P also must be of true, then only the conjunction will be of true. We have to search for T and T, but here it is of T and F, and in the second case it is of F and T. So here we won't get the conjunction as true, but we will be getting the conjunction as false in both the cases. Then now here fourth column consists of F, that is the false statements, so let us take the false statements in both the cases as F and F. Then now, so here in the first case, in order to prove P or negation P is identically equals to T, so P or negation P is under the third column and T is under the fourth column. So we have to observe third and fourth column truth values. The truth values are of T and T in the third case, that is the third column, and T and T under the fourth column. So therefore the truth values under the third and fourth columns are similar, therefore we can write as P or negation P is identically equals to T in the first case. Whereas in the second case, so here P and negation P, left hand side is under the third column and F is under the fourth column. We have to observe the truth values of third and fourth columns, whereas here F and F are the truth values of the under the third column and F and F are the truth values of the fourth column. So therefore since the truth values of third and fourth columns are similar, therefore the third column, that is the P and negation P, is identically equals to F, which is under the fourth column. So here we can write it as, since the truth values of columns 3 and as well as 4 are similar in both the cases respectively. So hence we can write it as, in the first case, that is P or negation P is identically equals to T, and in the second case P and negation P is identically equals to F in the second case. So in this manner we have proved both the cases, so hence it is proved. Then now let us go for the complement laws of part 2.